All right, Robin. 6 minutes after 10 o'clock. Later on, the lieutenant governor coming in, right?
Yeah.
That's kind of exciting.
Yep.
Earlier this morning, famous recording artist on the air.
Gary Chapman.
Famous TV star, his wife, right?
Yep, Kathy
and a little while
Pearsall.
ago, the guy who explored the Oklahoma City or Edward R. Murrow building bombing,
That's right.
And we have an Emmy Award winner coming on 11 o'clock, right? But I am not excited about any of them as much as I am our next guest, because he's going to. I am a nerd at heart. And he's going to talk about black holes. And this is a subject that just fascinates me. I don't know a thing about him. Michael Finkel is who I'm referring to. He's a journalist for National Geographic. He's reported from more than 50 nations across 6 continents. I'm guessing the missing continent is Antarctica. He'll fill me in on that.
Unless he was there for the Sports Illustrated swimsuit issue. He'll be the photographer.
Does National Geographic have a swimsuit issue? I don't know. He's going to talk about the star eaters, the black holes, the story of black holes, the cover story in the March 2014 edition of National Geographic magazine. And the only thing I want to say is when you look up, and I think from what I understand from Antoinette, his publicist, there is one that's going to be observed soon. He's going to help me understand this. And also the way I understand it is we're observing it soon, but it actually happened like a gazillion years ago.
Yeah.
So it's like we're watching an old movie or something. It's just fascinating how it's even possible. Michael Finkel. Good morning, Michael.
Good morning.
Where are you?
I'm in Bozeman, Montana, but I come from a heavily Gator family. My wife went to the University of Florida, and so I am a Gator fan by default.
Oh, go Gators.
So what's the continent? Am I right? Is it Antarctica?
It is Antarctica. You're right. I'm looking forward. If you'd like to go down with me, let's get that last continent off the list.
You
There
got
you
it.
go.
You got it. I'm there. we spoke to a lady who jogged in Antarctica. Remember, Robin? She did a marathon down there.
Yeah, she did a marathon.
And I joked. I said, "Did you trip over any penguins?" And she said, "Yes."
Yeah.
She said she was 80. Was she 83?
Yeah, 83
Unbelievable.
years old, yeah.
Well,
Something else.
You got to get down there, Michael, just so you can put it on your resume. Been to all 7 continents. So, am I right? We're about to see, or scientists are about to see, an actual swallowing of a star?
Yeah, let's start with a little bit of black hole basics. If you don't mind.
Black hole basics.
First, black holes are real. Second, what are they? A black hole is a dead star. Now, all stars will eventually run out of fuel. We don't have to worry. Our own sun has about 5 billion years left, but it will run out of fuel and die. Now, when our sun dies, it's not going to become a black hole. It's not big enough. But you take a star about 20 times bigger than our sun, which there's plenty of them around. When one of those stars dies, the outer layers are ejected, and that's called a supernova, and people have pretty much heard of this beautiful explosion. In fact, the material ejected in a supernova formed all of us. We're all made out of stardust. But really interesting stuff happens in the middle of one of these giant stars. It runs out of fuel, and what happens to the core of this star is that it collapses. It collapses inward, and gravity takes over, and it crushes this star smaller and smaller, denser and denser, until essentially it disappears from the universe. Crazy, but absolutely true. The energy required to escape the gravity of a black hole is greater than the speed of light, and nothing moves faster than light, so nothing escapes a black hole. It is a one-way doorway.
And where does it lead to?
We'll have to get. This is the true dorm room conversation. Let's stick on Let's stick on this side of the dorm room for just a minute.
All right.
Okay.
So am I right?
I'm happy to get into that.
All right. Am I right that if we do observe one, that it indeed happened a gazillion years ago? I don't even know what number to use, but I mean, it happened a long.
We will get into time and black holes. There are enormous black holes. Real, true, this is not science fiction, at the center of every galaxy. We live in the Milky Way galaxy. The Milky Way galaxy looks a little bit like a pinwheel, and we live in the suburbs. But at the very center of that pinwheel is a black hole. It has the fancy name Sagittarius A star. Sagittarius A star.
Are we all going that direction?
Well, yes. So Sagittarius A star is about 4 million times more massive than our sun. 4 million suns in a black hole. But let me tell you guys out there, of all the things to worry about in the world, and there are plenty of them, we do not have to worry about being sucked into a black hole. So let's just cross that off our list. I am here to relieve you of that worry.
Thank you.
But somewhere out in the universe, somebody does, right? I mean, if there was somebody out there.
Right. So we're good. Space is vast. Now, you were mentioning this picture. We have proved that black holes exist, but this is more mathematical proof, and I'm going to stay away from all math in this conversation.
Okay.
Now, wouldn't it be
Thank
nice to see a picture for the rest of us who don't have great math? Let's just see what it looks like. In the next year, for the first time in history, we should take an image of a black hole in action. This Sagittarius A star, our neighborhood black hole at the center of the Milky Way, is right preparing to have a meal. A large gas cloud is being sucked toward it, and radio telescopes, which are telescopes that operate on radio waves. They're sort of like X-rays at the hospital. You can cut through the interstellar dust and see. So anyway, all the major radio telescopes on Earth are going to focus on Sagittarius A star, our neighborhood black hole, and we're going to form a telescope essentially by knitting it together the size of planet Earth, which is really cool. But that star, the black hole is far away. We need to do that. And we will see a black hole eating a gas cloud. And it's going to look a little bit like, you ever seen a picture of a total eclipse of the sun? It basically is the moon in front of the sun. So it looks like a black hole in front of the sun with a ring around it.
Right.
That's basically what the picture is going to look like. You can't see a black hole. It's too dark. Light doesn't come out of it. But you can see the ring of debris around it. And we should have that image in about a year. And that will be final proof to almost all the rest of us that black holes are not just science fiction.
Okay,
they're real.
so let me put two questions in one so that you can answer them, I guess, that way. Is what we're viewing something that happened a long time ago? Well, I guess you already answered that. But could it affect us? And if it could, then wouldn't it have already affected us? I mean, since it happened so long ago.
Yeah, okay. Let's talk about a few things about space. Nothing moves faster than the speed of light. We're stuck with that. That's our universal speed limit. Light is fast, 186,000 miles a second, but nothing moves faster. So if something is a light, for example, when we look at the sun, we're looking 8 minutes into the past because the sun is 8 light minutes away.
Okay.
So if the sun died now, we would still see the sun for 8 more minutes. Is that clear at all?
That's very clear, yes.
Okay, exactly. So Sagittarius A star is 24,000 light years away.
24,000, okay.
24,000, meaning that when the light from the stuff around Sagittarius A star reaches Earth, it's 24,000 years old. When we look up at the sky at night and we see stars, some of those stars died millions of years ago, but their light is just reaching us now. It's a mind bender, but it's true. We're looking into the past. So we don't really make those. When we say it's happening in the next year, that means the light from that event is happening in the next year. It's one of those things with the vastness of space that you just have to sort of get your head around and accept. I love this kind of stuff, but it certainly is a head scratcher.
It is. But if there's a reaction and an opposite, whatever they say, reaction, does that reaction reverberate as far away as we are? I mean, will that, in addition to the light reaching us, will there be something else reaching us?
No, we're fine. I mentioned earlier that we don't have to worry about being sucked into a black hole. But let me tell you what that black hole in the center of the Milky Way does. It's really interesting. It churns up, basically we're seeing this gas cloud, it churns up old stuff. A black hole is not only really tiny and really, really heavy, but it spins extremely rapidly. I like to think of it as I would have called it a black whirlpool. It's a spinning hole in space. And you ever sharpen a knife on a sharpening wheel? You have a spinning wheel, you put a knife on the edge, and all these sparks fly off.
Yeah.
You've probably seen that before. Yeah. That's almost exactly what happens when a black hole eats something. So this gas cloud comes towards it. Some material will fall into the middle, but a lot of it is going to be flung off. And I'm talking cosmic scale flinging. It's going to fling gas and particles to the outer edge of the Milky Way. So here's what I'm saying. Black hole at the center of the Milky Way, Sagittarius A star is its name, is the ultimate recycling machine. Old stars in the middle get churned up, just like those sparks on a sharpening wheel. Gas and stuff get flung to the outer edge of the Milky Way. sort of where we're living, they form new, it cools, it coalesces, and it forms new stars. It's like the star regulator of the Milky Way galaxy, and we're thinking that that's how all galaxies work. If we didn't have a black hole, we should, instead of being afraid of black holes, be very thankful. If we didn't have a black hole at the center of the Milky Way, there probably would be no sun, meaning there would be no Earth, meaning there would be none of us.
None of us. Okay, so it's an important part of the whole process. Yeah.
Could scientists send a rocket into the middle of the black hole with a camera and stuff on it, since it is gravity right there? And then could that black hole suck that camera in there, and then we can actually see the workings?
I love questions like this. Okay, are we ready to get a little head spinny here?
Yeah.
Are we ready? Okay,
Yeah.
Brace yourself. I know it's morning time.
Yeah.
We should really be waiting till the midnight showing of something for this. But let's get into this. Let's get into my favorite stuff about black holes. First thing is this time machine concept. This is all, by the way, I just want to make an announcement. This is all absolutely true, verified thousands of times over. Now, let's talk about time in black holes. Do you ever heard of the phrase "time is relative"? We probably all heard
Yes.
that time is relative.
Yes.
Now, it's going to take me about a minute and a half here to explain this. You got to just come with me on this journey.
Okay.
Okay.
I'll try and be clear
I
as
love
possible and no math. Here we go. Time is relative. What does that mean? It means that time does not tick at the same rate for everybody. Come with me here. If you put an extremely accurate clock on every floor of a skyscraper here on Earth, we'll stick here on Earth, they will all tick at a slightly different rate. Why? What? The clocks on the ground floors of this building, closer to the center of the Earth, where gravity is stronger, will go a little bit slower than the clocks on the top floor. This is true. We don't notice it because we're talking about billionths of a second, so it doesn't really apply on human terms.
Right.
However, GPS satellites, they have different clocks than those on Earth. If GPS satellites didn't, GPS would not work. Now, that's just little old Earth, where gravity is not very strong. Throw a baseball up in the air, you've defeated Earth's gravity for a couple of seconds. Raise your hand, you've defeated Earth's gravity. Let's move over to Sagittarius A star, our black hole at the center of a Milky Way galaxy, where gravity is extreme. Now, I'm going to get in my spaceship, and I'm going to travel over to Sagittarius A star. You guys hang out. Larry, Robin, you hang out here on Earth. You keep a wristwatch on your wrist.
Okay.
I'll put a wristwatch on my wrist. Are we together now?
Yes,
still?
yes.
Okay. I'm going to fly right to the edge of Sagittarius A star. There's this boundary called the event horizon. Once you cross that event horizon, you slip into the black hole. You're lost forever. Let me just go right to the very
Just go to the edge. Okay, yeah. We don't want to lose you.
Right there. I'm right here. I got my watch on my wrist. You got your watch on your wrist. For every minute I spend there, this is true, for every minute I spend there, 1,000 years could pass on Earth.
Wow.
It's crazy, but it's true. Einstein understood this first, that gravity is more powerful than time. It just doesn't seem possible, but it is fact that gravity overwhelms time. I won't live any longer than you. My heart will not beat any more times than yours, but I'll come back to Earth and it'll be the year 3000, if that were possible to actually fly there. But it just happens. It is very hard to get your head around, but it's true.
Okay.
That's the way the universe works.
It is hard. It is hard. So, and I understand that the upper floor in your skyscraper example, those clocks are going faster, right there.
Just a microbit faster,
Okay.
because the center of the Earth, when you go up in space, there's not as much gravity. It's the gravitational pull of the Earth is less up on the top floors.
So does that mean the center of the Earth is actually older or younger than the crust of the Earth?
What it means is that gravity is pulling inward. So the reason why the planet stays together,
Right.
it doesn't just fly off into space, is that we're a nice sphere, which is the only shape we could be, because everything's pulling towards the center. We're all being held together. The highest, just like your ears sort of pop when you go down an elevator. If you were to go to the center of the Earth or underwater,
Right.
where gravity is stronger, eventually you would be crushed. If you got out of a
Right.
submarine here on planet Earth, you would be crumpled and crushed.
So let me go back to the 1 second versus 1,000 years statement. So if we're watching this in the next year, we're watching this star getting eaten by a black hole, and let's say it takes a month to see the whole thing unfold.
Right.
If you broke the month down into seconds, how many seconds are in a month? Is that how many thousand years it actually took to happen?
Yeah, there's a lot of crazy stuff. Let's have another fun example. Come with me on the spaceship. Let's all go to Sagittarius A star.
Why, from Antarctica to
yeah, Sagittarius A star.
All three of us are going on the spaceship to Sagittarius A star. Now, you guys hang out in the spaceship and take a beautiful look at Sagittarius A star. I'm going to get out of the spaceship, and because I'm in a crazy mood, I'm just going to jump in. Here's what's going to happen. Again, we both have wristwatches on our wrists. They work fine. They're Timexes. They're great. You're going to watch me right through the windshield of your spaceship. This is, again, very hard to believe, but 100% true. I'm going to get closer to the edge of the black hole, and I'm going to jump in. Guess what you're going to see? You're not going to see me move. It's going to look like I'm frozen. You're going to be like, Mike is just, he's not doing anything. He's stuck there. And do you know how long I'm going to be frozen there at the edge of that black hole? Basically, for all eternity. It's going to look like it. That's what it's going to look like, because it seems...
But your experience won't be that. Your experience...
We're about to go into mine, which is even trippier. Right, you're going to be... It looks like I'm frozen. It's crazy. In fact, one of the earlier names for black holes, the phrase black hole is only from 1967. They used to be called frozen stars. Again, this is stuff that seems crazier than science fiction, but it's true. Gravity defeats time. Gravity is so strong at a black hole that it just looks like I'm frozen. It just looks that way. Time is relative. You experience it differently than me. Now, let's get crazy. What happens to me? What happens to me when I jump into that black hole? I have a wristwatch on my wrist, and I jump past the event horizon. It looks to me like I've frozen forever. What happens to me? You'll never guess what happens to me. Nothing. Nothing. I jump in. My wristwatch is ticking along perfectly fine.
Right.
It's as if I've crossed the equator. Nothing happens when you cross the equator. You don't suddenly burn up. It's an imaginary line.
Right.
However, I am now lost to the rest of the universe forever. Crazy. But nothing seems to happen to me. Now, that only lasts a couple of minutes. Unfortunately, I get shredded to particles in a few more minutes. But I cross the event horizon, and I'm fine. Now, I love this kind of stuff. What's in there? What happens?
Right.
What is really in there? What am I going to see? Unfortunately, I think, Robin, you asked about a video camera. What happens if I did take a video? Unfortunately, I could never post that video to YouTube because it's a one-way hole. There is no way out. So there's just no way to get that video back out to the rest of the universe.
And is the time always forward, or does it go backwards? Is there a...
Yeah, it always is forward, or else the universe wouldn't work. You can go fast forward, but there is no reverse.
No reverse.
It wouldn't work.
I have a question, and I'm not trying to say I know anything about anything, but assuming the Big Bang theory is exactly accurate, and that all matter started off with the Big Bang, and there's a place somewhere in the universe where that happened, and then everything spewed out from there, right?
Yes.
So which means we're looking at particles, even if they are gigantic and a million billion times bigger than the sun, we're looking at particles from that explosion, right? That happened gazillion years ago, or whatever. Are we able to actually see, because of our distance, the light that actually comes from the Big Bang, or
yeah?
Could we see ourselves? Are we out there someplace reflecting back at ourselves?
Okay, now we've really gotten. Let's back it up a little bit. The entire universe is about 14 billion years old. A little bit less than that. 14 billion years ago, every single thing in the universe was compacted into a tiny, tiny, tiny point, which is called, physicists call it a singularity, which is basically a fancy word for a question mark. But it was in a tiny point, and it exploded, the Big Bang, and has been expanding ever since. 14 billion years ago. But we have powerful enough machines so we can actually hear the echo of the Big Bang, which still exists. If you drew a circle, if you were 14, basically we're in the middle of a bubble that's 14 billion light years in radius, so 28 billion light years across. So that's where we live, an expanding bubble. It was a tiny little point, and we've blown up to a bubble. We can hear the echo of that bang at the very edges.
Wow.
Sometimes I think about the universe as, imagine a balloon that someone's been blowing up for 14 billion years. That's the edges. The skin of the balloon is the echo of the Big Bang, and it's still traveling outward. We don't know if it's going to stop and contract. We don't know. But that's called a singularity. And if you want to get even crazier, I talked about what might happen to me if I fell into a black hole, this one-way doorway. Well, I would get shredded. Eventually, gravity would become so extreme. The nice physicist term is spaghettification. If I was falling feet first down a black hole, the pull on my feet would be so much greater than the pull on my head, even though I'm less than 6 feet tall. That difference is enough so that I would be stretched like a piece of spaghetti, spaghettified.
Oh, wow.
Broken into a bunch of particles. Unfortunately, my video camera would have the same would happen to that.
Yeah.
Okay.
But particles of me would reach the bottom of this black hole. Now, what's in there? What do I hit? What do I reach? Well, most physicists say, I don't know. I don't know. It's a one-way doorway.
That's the answer I would give.
Know.
Yeah, that would be my answer.
But not all physicists say that. Now, I just want to make a little warning here that now I am in the realm of theory. This time travel thing, that is fact. This gravitational thing, fact. Black hole in the center of the Milky Way, fact. Let's get into theory, hypothesis. This is not guesses. These are high-powered thinkers at the greatest universities in the world, but these are guesses. These are hypotheses now, what's inside a black hole. But there's some cool thoughts. One of the thoughts is this. The object in the center of a black hole is extremely dense, extremely small. When I say Sagittarius A star has the weight of 4 million suns, that weight is compacted into something. When I say the tip of a pin, that is so much of an exaggeration. The tip of a pin is so much bigger than what it actually is. I'm talking the weight of 4 million suns in a particle that is a trillion times smaller than the tip of a pin. And yet that's how much it weighs. Crazy, but this is also close to being true.
Wow.
It's thought to be true.
And we can't get $10.10 an hour as a minimum wage.
That's right.
That's hard to believe.
You know what they call that? You know what they call that little tiny particle in the center of a black hole? They call it a singularity, just like what they call the tiny thing that started before the Big Bang, a singularity. There is a theory which I love, which may or may not be true, but like I said, this isn't just people in the dorm rooms coming up with this. These are physicists. That singularity at the center of a black hole is just like the singularity that started the Big Bang, and it could explode also and become its own universe. It's like a wormhole to another universe.
So it could be parallel universes, as some science fiction writers write.
And some physicists also write.
Part of the history of the material that was sent to us said that black hole thinking had been initially mentioned in a report in 1783.
Wow.
Now, that is really amazing to me that way back then, there were physicists and scientists that were actually thinking about the black hole theory.
Yeah, it's been a really interesting history. Basically, the term black hole is only from 1967. Before that, they used to call them frozen stars or collapsed stars, and there were always a couple of rogue thinkers for at least 200 years, as you mentioned, where some scientists would say, I wonder if this was possible, if something could become so dense that it could even asphyxiate light. Now, most mainstream thinkers, including Albert Einstein, one of the most imaginative physicists in history, said, no way are black holes real. It's just too extreme for nature to permit. But Einstein, who died in the 1950s, was wrong. In the 1960s and late 70s, we invented new ways of looking into space, not just visible spectrum, but X-rays and radio waves, which allowed us to really peer into the center of galaxies, and we saw, wow, black holes are not only real, there's trillions of them in the universe.
Wow.
They're common.
Oh, my goodness. We are fascinated. I feel sorry for you. You've got to explain this again to another radio geek now. Michael, what a fascinating, you've done such a great job as a journalist explaining it to us on the radio. I'm looking forward to the National Geographic issue that covers this story, the March 2014 edition. The story is Star Eater, the story of black holes, and it's written by Michael Finkel, who has done all of this research to help us understand something so complex. I think my head is hurting right now.
Yeah, you're wonderful, Mike.
Michael, do you want to give us any websites or anything, or do we just go get the magazine? Is it on the online version of the magazine?
Just go to www.nationalgeographic.com or look on the newsstand, or just get your teeth cleaned this month, and I'm sure you'll see it.
Wow. I was looking so forward to this one. It went so fast, but it was really just a nanosecond. I can't even think of whatever. Michael Finkel, thank you for being on the air with us today.
My pleasure, and I hope it wasn't too much brain strain for early in the morning.
Yeah, I got to go get aspirin or something. No, I'm teasing. I'm teasing. That was great. We'll be right back.
We're listening to WOCA News Talk 1370, Ocala's source for what's happening in today's hottest, up-to-date news and topics.